Hello, my name is Caroline. I'm presenting to you today concerning a software failure that took place in California several years ago in an air traffic control center. So this presentation is a case study concerning that failure. We'll be looking at what happened and what we can learn from this in the future to avoid this sort of problem. On September 14, 2004, the Air Route Traffic Control Center in Palmdale, California lost all voice communications with approximately 400 airplanes that were flying in the southwestern region of the United States. The incident resulted from a system shutdown in the center's voice switching and control system. And in addition to that communication system failing, the backup system also failed shortly after it was activated. The communication was severed for 3.5 hours, and this communication was severed between the air traffic controllers and crew members in other air traffic control centers, along with communications between pilots and the air traffic control centers. Fortunately, there were no casualties or airplane crashes, but there were definitely a few close encounters, and thankfully, most of the airplanes that were in the air at the time had a traffic collision avoidance system, which is built in on most commercial airliners, and what it does is it sends out a signal for one airplane to go up and the other one to go down when they're in very close proximity to each other, so they end up avoiding each other and avoiding a crash. So a description of the equipment that was used in the air traffic control center is called the voice switching and control system, and it's designed and manufactured by Harris Corporation. This was part of a 15-year, $1.6 billion contract that was awarded to Harris by the FAA, and it's been in use since the mid-90s. The system enables flight controllers to communicate with flight crew and other controllers by selecting a phone line on the VSCS's touchscreen. In 2001, Harris released an equipment and software upgrade to the VSCS, which is the VSCS Control Subsystem Upgrade, or VCSU. The VCSU is a control system for the VSCS, and it continuously performs health checks on the system through built-in tests. The VSCS operating system was changed from a Unix operating system to a Microsoft Windows, and the hardware was also upgraded to Dell computers. So what went wrong on the incident in 2004? A technician responsible for rebooting the system every 30 days failed to do so. In addition to that, a separate technician failed to configure the backup system correctly. So why did the system have to be rebooted every 30 days anyway, right? The VCSU uses a Windows system that has a countdown timer in it, and it's called a GetTickCount API, and it's used to send periodic health checks to the VSCS. The timer counts down from 2 to 32nd power of milliseconds, which is the maximum memory capacity for the API. So in other words, it had 32 bits, or a total capacity of 4 billion milliseconds, and it took the timer 49.7 days to reach 0, and when it did, the system shuts down to impede data overload. This bug in the Windows system is the reason that the FAA implemented the mandatory reboot every 30 days, and it was done to cycle the clock way before it reached 0 and shut down the system. So, taking a look at how the system failed, we're going to take a look first at the manufacturer, Harris Corporation, and their involvement in this process, or in this failure. They were allegedly aware of the Windows flaw. A company that's designated as the union technician to maintain the VSCS stated in an article that Harris was aware of this flaw, but they weren't sure of how it would affect the system. Harris also released a press release in 2001 stating that they successfully completed the functional acceptance test for the VCSU. which is interesting because in a functional test, or a functional acceptance test, they really want to do black box testing. So they wouldn't really have gone into the nitty-gritty of the system to find out all of these internal flaws. So in their software validation and verification process, the bug could have been found during the system testing stage, but if Harris was following the FAA's requirements list, they were most likely not required to test the system to the point of failure, or 49.7 days, because the FAA wouldn't have even known to put that as a requirement because they weren't aware of this system flaw. So if Harris did know of this issue and didn't really pursue it, it might have been an error on their part, but it's difficult to say that they would have even been able to really gone into more detail and assess the situation, or assess what that could have what that could have done to the system. Looking further into the customer now, which would be the Federal Aviation Administration, or the FAA, they became aware of the Windows flaw 1 year before the Palmdale incident took place, because the same thing happened in Atlanta and Houston before the Palmdale incident. So they were in the process of implementing a solution, but it didn't happen in time to prevent the incident in Palmdale. They later released a software patch to automatically reboot the system, however, so it didn't need human intervention. The FAA struggled with the modernization of its air traffic control system since its inception in 1981. So this has definitely been a long time coming. The FAA has tried to modernize the air traffic control system and upgrade and implement new technologies since that time, and they've encountered numerous delays and issues that have been addressed in different studies and different documentation. So one of these studies was conducted by the U.S. Government Accountability Office, and this was actually demanded by Congress to do this because the FAA was so over budget and had so many delays that Congress wanted to know why this was happening. So the study was conducted, and it pointed out the agency's numerous shortcomings over the years. In 1995, the study actually deemed the FAA's NAS modernization, which is a national airspace system, they deemed it as a high-risk area because of the size and complexity of the program and the FAA's many failures in meeting project costs, schedule, and performance goals. A 2004 report also showed similar things with Similar River, and it stated that the agency's senior IT investment board didn't partake in regular reviews of systems that had completed development and become operational, such as the VSCS and VSCS. The agency also had not put into place any post-implementation reviews of its major investments to validate that they are providing the expected benefits after they become operational. Thankfully, various changes in procedures and policies have been put into place since then to address these criticisms. But during the time that this incident took place, this is the scenario the FAA was facing. They were completely over budget on a lot of projects, including the VSCS and the VCSU. It took a lot more time. They experienced a lot of delays in implementing these changes, so they were definitely facing a lot of issues internally. They also had a lot of managerial problems. They went through 7 different managers or directors in a period of 10 years, so you can only imagine the infrastructure issues that they were experiencing at the time. So that doesn't make it easy to make anything streamlined, especially when you're the people that are directing the company are fluctuating as much as it did. So this image here is actually an example of, it's a little piece of the FAA's project implementation plan for the VSCS, and we're looking at this because of how detailed it is in describing the expectations for the VSCS during the operational test and evaluation phase. The VSCS had very, very rigorous testing procedures that were discussed throughout this document, and this is just one small piece of it. You can see here that it discusses fulfillment of all user operational requirements, readiness and suitability for field deployment, transition procedures to radio equipment and fallback systems and all of these things. So the VSCS definitely had all of these things in place, but it was difficult to find, actually I did not find any such documentation for the VCSU. So the only thing I did find was that the VCSU was managed by the FAA's acquisition management system, and this management system had not been in place at the inception of the VSCS program. This was actually implemented in 1996, again, as requested by Congress, because the FAA needed a method to improve management of their investments throughout their product lifecycle. So this was their solution that was implemented in 1996, and you can see that it goes through from the beginning, determining what the new service needs are, and then going through a process of research and system analysis, mission analysis, investments, investment decision, implementing the solution, and then finally managing the product while it's in service. So there are several organizations within the FAA and some outside of it that are involved in this process. So that makes it that much more difficult to actually get anything done, because it's a step-by-step procedure and there's a lot of parties that are involved. So once a project goes to the in-service management phase of AMS, the specific service organization within the FAA are assigned the task of managing services for that project throughout its life cycle, as I mentioned before. So this was actually the case for the VCSU. It was in that in-service management phase. The project is also continually monitored to assess that it's still living up to expectations, and if not, the process in Figure 2 is begun again to identify the changes that are needed, if any. The AMS doesn't specify requirements that are particular to the VCSU, but it does offer perspective on the procedure the FAA used to implement it initially, and also how the solution for the system shutdown may have been addressed. So if it did have to go and cycle through this entire process here, that could explain why it took more than a year for them to come up with a software patch to resolve the issue of the system shutting down after the countdown timer went to 0. So in conclusion, the Palmdale incident was definitely an oversight on more than one party. So it wasn't just the technicians that failed to do their job at that point, and it was also, it took part of the FAA's involvement and part of Harris Corporation, the manufacturer, as well. So all of these different parties were involved in some way for this incident taking place. And again, thankfully, no casualties were reported or any airplane crashes, but it was definitely close for comfort. So some of the incidents like this make some things definitely very clear. Solutions are seldom as clear-cut as some software engineering textbooks may imply. There are definitely real-world factors that we have to consider, such as costs, time to uncover and fix a problem, human errors, and the list goes on. And another point that it makes clear as well is the importance, as well as the difficulty, of standardizing best practices in solving software engineering problems. It's definitely not as streamlined to make procedures in solving these problems standardized. There are so many different scenarios that can be applicable, and when you put in the real world scenarios of budgets and time constraints and whether or not people are even knowledgeable enough to assess a situation or a problem, all of these things have to be taken into consideration. So it's important to continue research and development of software development procedures, and to also make people more and more knowledgeable of these scenarios, because the world is definitely becoming more dependent on technology and not less, for sure. So the more involved we are in technology in our day-to-day, the more we need to understand these processes and better implement solutions for them. So some of the questions that can be derived from this case study. Number one, should or could Harris Corporation have tested further to determine the system's behavior once they did discover that that timer would go to 0? Well, maybe they could have, but maybe not. Again, because of budget and time constraints, possibly. If you as a business have a budget that you're given by your customer, and you have deadlines that need to be met, it might not be feasible to dig deeper into that problem to assess what could happen. Additional testing may not have even been part of the customer's requirements. Again, the FAA wouldn't have known to require system testing for 50 days, so if Harris was only going off of the FAA's requirements, they wouldn't have gone any further to dig deeper and discover why this system would have taken place. Could they have done it? Possibly. But again, if they had dug deeper into that problem and found out that the timer maybe didn't mean anything, then it would have been a waste of the customer's time and money. And on the flip side, though, if they did discover that the timer, if they had gone apart from the requirements and discovered that the timer would have caused this issue, it would have been a good thing and would have avoided the problem altogether, but it would have been difficult to say that they had the time and the budget for this. Number two, why did the FAA take so long to implement the software patch? So doing further studies like that of the Government's Accountability Office, we would suggest that the FAA lacked the structured processes to quickly address incidents such as this, particularly if the implementation of a solution meant going through a lengthy process like AMS in the lifecycle management process. It definitely would have been a bureaucratic and lengthy procedure to get to a solution. So they definitely should have had a plan to address emergency situations such as this, and in that case what they decided to do to put a band-aid on the solution, on the problem for the moment, was to implement that reboot system, the manual reboot system. So, but that led to further problems of training personnel adequately for that and so forth, so it actually caused further problems and possibly even more money to assess that. Number three, why did the technicians fail to reboot the system and configure the backup system properly? Representatives of the Professional Airway Systems Specialists, which is the union of technicians who maintain the communication systems for the FAA, they said the technicians did not receive adequate training from the FAA. So that goes back to what I just discussed in question number two. They didn't have enough time, most likely, to train these personnel properly, because this all happened within a span of a year. So it definitely had to be a rushed scenario, and you can understand why training may not have been adequate for these technicians. So number four, how did the air traffic controllers address the system shutdown when it happened? The controllers in the Palmdale Center were quick enough to use their cell phones to notify controllers in the area of the incident, so they could resume communications and control in the interim. What is one lesson learned from this incident? Create a backup for the backup. In this case, had the backup not failed, the VSCS system wouldn't have failed altogether and everything would have been hunky-dory. But because the backup system was configured incorrectly, everything crashed and there was no immediate resolution to the problem. So, in a scenario as this, where it's so critical to not have software failures or any kind of failure, you definitely want to have a second backup system for the backup. Redundancy is definitely not the bad thing in this case. So that is it for the presentation. Thank you very much for your time.